Hi everybody, it's Friday. We made it to the end of the week, and I'll be completely honest, I just finished recording this whole Friday part, and then my computer shut down and didn't save. So I'm doing it again. So hopefully it'll go even more smoothly for me. All right, we're gonna work on fractions. We're gonna work on fractions greater than 1 and review a few of those concepts that we did about a month ago. All right, let's look at this line. The top number line is showing us 0 to 1. And on this number line at the bottom, we're going from 0 to 1 also. Both of them are the same lengths. The difference is the top line, we're partitioned the line into fourths. So we count up by fourths to get to 4/4. The bottom one is one giant jump to get to 1. So that one giant, a little bit ugly jump of mine, would be one jump out of 1 to get us equivalent to 1 whole. Just like 4/4 is equivalent to 1 whole. Remember when the numerator and denominator are the same. Here we have fourths also, but we're going a little bit farther. We're going to 2. So you know that 4/4 will be at 1. Do you know what will be at 2? Okay, so here we go. 7/4 is up next, and then we have 8/4. A reminder here that our fraction notation, the way we write it, is just another symbol for division. So we can also look at this as if I have 8 parts, how many, and I have to share them into 4 plates. You get 2 per plate. Down here, again, we're having that 1 out of 1 jump, 1/1. So I'm adding, this is extra sloppy when I don't get to use my little tool. 1 each time, and then if I do that again, sorry about that, I'm adding 1 again. So remember, this denominator is just the name. So when I get here, the name stays the same. It's going to be 2/1, and 2/1 is also equivalent to 2. Okay, the question on this slide says how many fifths? We could look at this a couple of different ways. If we start at 0, we have 0/5, and we're counting up and adding 1/5 each time we jump. How much neater that can be when I'm not using the mouse. And we keep going because fifths is the name of our jumps. We're adding a 5th each time, so we're still keeping with the fifths. So 5/5. You also know that's equivalent to 1 whole. Now this could all look really different if we started at a different amount. I'm going to go ahead and erase these fifths. We're still going to be adding fifths each time, but let's start, well, we had 5/5 before. Let's go on to 6/5, 7/5, 8/5. It just keeps going on and on and on and on. And we ended at 11/5 on this. Now this could keep going. We could literally have, let's see, I don't really want that arrow there. We could literally have a number line that continues, and maybe we end up here at like 97/5, 98/5. It doesn't matter, we can still be there. You will notice though that there are times where you get to a whole, and probably thinking back, because patterns are really important in math, what number would we get to a whole? Every 5th. So do you see anything in this number line, the first one that we kind of did here, that would be possibly the same equivalent as a whole number? Yeah, let's look at 10/5. 10/5 is the same as 2. 10 shared by 5 is 2, so 2 wholes. There's another one up in this section that we might find too. So it has to be in our 5s counting pattern, doesn't it? So this one here, I don't know how many 5s are in 100. Sometimes it's easier to think about 10s. You know 10 10s are 100, so we have to double that number. It's going to be 20. That's pretty fun. All right, let's remind ourselves. These are, a lot of these slides I'm reusing from previous weeks just to help us refresh our memory about these wholes. So this is 1 whole. So I always look at the 1 whole to figure out the name or the denominator. So because this is partitioned into thirds, the denominator is thirds. There are 3 of the thirds shaded, which is equivalent to 1. So on the second one, I do see that I have 2 holes, but not all 2 of the holes are shaded in. I have to look at one of the wholes to decide what my denominator is. What's the name of the types of parts? Those are halves, so we represent with a 2 in the denominator. There are 3 halves shaded. Now we have 1, 2, 3 wholes here. So we know this is going to be the same thing as 3 wholes. But how many parts are there? Don't say no parts. There's 1 part. And we have 3 of those. So 3 over 1 is the same thing as 3. Let's practice down here. 1, 2, 3, 4. Denominator, the name of the parts is fourths. We have 4 fourths shaded, and that's equal to 1. Remember, look at the 1 whole. We have halves. We have 1, 2, 3, 4 halves shaded. Look at 1 whole. How many parts? 1. You didn't fall for it that time, and there are 4 of them. That's the same thing as 4 wholes. Let's go back to the halves. This is the same as 2 wholes. Let's look at one more page. Sorry, we're going to look at one more page of these. So remember, we look at the whole to figure out the name of in our denominator. This one is going to be 6th. We have 6 shaded in, which is 1 whole. Look at 1 whole. We have thirds, but there are 1, 2, 3, 4, 5, 6 thirds. And how many wholes is that? 2. 6 shared by 3 is 2. How many parts? 1. We have 1, 2, 3, 4, 5, 6. So 6 over 1, which is the same thing as having 6 whole things. Great. Okay, so let's practice with this. We're going to fill in the missing whole numbers in the boxes below the number line and rename the whole numbers as fractions. So it's this idea that if we're jumping from 0 to 1, we're not partitioning it into fourths or anything. It's just one jump, so it's 1 over 1. So every time we jump, it's 1 over 1. So that would, mean this is 0 over 1. Add 1, 1 to that. This is 1 over 1. Add 1 over 1. Now we have 2 over 1. 3 over 1. Do you see the pattern? 4 over 1. 5 over 1. 6 over 1. Let's take a time out and look at that. I have 5 cookies shared onto one plate. Each plate, that one plate will get 5 cookies. So that makes sense why this is equivalent in the same spot as 5 as a whole number and 5 over 1. Okay, so we're still doing that same jump. We're just jumping up a little bit to some higher numbers. 10 over 1, 11 over 1, 12 over 1, 13 over 1, 14 over 1, 15 over 1, 16 over 1. We'll fill in those whole numbers below. So 10 over 1 is the same as 10. 11 over 1 is the same as 11. 14 over 1 is the same as 14. You can check by looking at these numbers before and after. Nicely done. So if we look at what the difference is between 2 over 1 and 2 halves. So 2 over 1, let's think of that idea of taking a jump of adding 1 over 1 each time, and we're doing 2 of those. So if I add 1 over 1 to nothing, I'm at 1 over 1. If I add that, then I'm going to be at 2 over 1. This is equal to 2 whole things. You can show that in a diagram also. Remember, they're not partitioned at all, just that whole is just like that. And they're going to be completely shaded in if you have 2 over 1. Like this. So you see that you have 2 wholes. The difference being that when I have 2 halves, let's look at that. You can think of a number line. If I start at 0, I'm going to be adding a half every time. Make that jump a little bigger. Plus a half. And I'm going to do that twice, so plus another half. And then I'm going to be at 2 halves. 2 halves is the same as one thing. Let's prove it with a picture. If I have my whole partitioned into halves, and that 2 of the halves are shaded in. So 2 halves is the same as 1 whole, but 2 over 1 is the same as 1 whole. And I kind of discussed that down here. 2 over 1 means there are 2 wholes, and the unit of each is 1 whole. 2 means there's 1 whole. 2 halves, means there's 1 whole. Let's look at some practice for the week. Today, I should say. You're going to go in Workbook B, page 107 to 108. Some pages you can go back and look at. Make sure you're finished from this week would be page 227 and 228 in Workbook B. The only one that is Workbook A is from Tuesday, page 165 and 179. Page 101 and 102 in Workbook B, 104 and 105 in Workbook B also. There'll be some practice pages on Seesaw and math tiles. You know what to do with those. All right, one more week of school after today. Thanks for your hard work. I'm looking to plan a kind of a fun activity project with math next week. So let's see how that goes. Have a great weekend. Take some time to just have some fun and relax your mind.